Hello, welcome back to Math 7 with Mr. Passon. Today we are continuing our unit on probability. Today we are talking about experimental and theoretical probability. This is Unit 11, Lesson 2. Okay, experimental and theoretical probability. Now you might have an idea. Experimental probability is the probabilities that you get from doing a physical experiment. Theoretical probability is the probability that you get from visualizing a model. We're going to keep those two ideas in mind. Experiment has to do with actually doing trials, and theoretical is based on a model. Okay, so let's talk about experimental probability. It is the ratio of the number of times an event occurs to the total number of trials. Let me just make that a little bit taller so that gets on the line like it's supposed to be. What does happen? Okay? Whereas theoretical probability is the probability of an event happening based on the possible outcomes. What should happen? Oh, get both O and the U in there. Okay, now we're going to use a spinner, and we're going to look at this situation here, and we're going to ask, what is the theoretical probability? Oh, I guess we should spin it 10 times. So we're going to put a little spinner on here. We're going to collect our results. Now it is challenging for me to do that here, but I'm going to do it over here with my simulator. I will be right back. Okay, so I've run my simulator, and the first one I get this one. Then I get this one. Then I got this one twice. Then I got this one. Then I got this one. Then I got 5, 0, 1, 2, 3, 4, 5. And then I got this one. Let's see if that's all my 10. Oh, that's not all 10. And then I got, this one's 7, 1, 2, 3, 4. This one twice. So let's see if that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yes, 10 spins. Excellent. So what is the theoretical probability of spinning with stripes? Well, there's one section with stripes, so that was 1 out of 8. Theory is based off of the outcomes that are there. What is the theoretical probability of getting a section with stars? There's 2 stars, so that is 2 out of 8, which is the same as 1 out of 4. What is the theoretical probability of not spinning a solid or striped section? So that means that you did not get this, so you had to get this one, or this one, or this one. So that is 3 out of 8. Alright, let me clear those. Oh, and then if we talk about our tally, I got, let's see, 2 with stripes, 1, 2, 3, 4, or 2 with stars. Alright, so I got 2 stars, 2 stripes, and I'm going to write this down so I can transfer it. I've got 1, 2, 3, 4 blank, or 4 solid, and then 2 polka dot. 2, 4, 6, 10. So I can clear this out. So for my stripes, I had 4. The total number of spins was 10. Thus the experimental probability was, stripes I only had 2. 2 out of 10. So my experimental probability is 2 divided by 10, or 1 divided by 5. Then the white ones, well, I had 4 of those out of 10 spins. So that was 4 out of 10. which is 2 out of 5. Okay, then dots. I had 2 dots out of 10 spins. So that's 2 divided by 10, and that's 1/5. Finally, stars. I had 2 out of 10, and I had thus 1/5. Alright, now they are not the same, and they could not be the same because I had 10 spins versus 8 spins. But even if I have the exact same number of spins, doesn't mean it's going to work out perfectly. So remember that experimental gives what should happen and what will happen if we do it enough times. It's going to be close to the right answer. Alright, so experiment rarely perfectly matches theory. Okay? They will be close, especially if we do enough spins, but they will never, or they will rarely be exact. So let's go ahead and continue on to page 2. Pause if you need to catch the notes. Okay, so relative frequency is the total number of successful attempts divided by the total number of trials. It can be used to make predictions. Alright, as the number of trials increases, the relative frequency of an event will approach the theoretical probability. So if we do enough spins, the relative frequency should approach the theoretical probability. Alright, now the spinner was at the right is spun 50 times and the results are shown in the table below. Complete the experiment below. The relative frequency, that is how many times it was spun out of the total. So that is 12 out of 50, which is 6 out of 25. Now, the next one, it would be 8 out of 50, which is the same as 4 out of 25. Next one is 13 out of 50, and that one's just going to stay 13 out of 50. That one does not simplify. Then we had 10 out of 50, which is going to reduce to 1/5. And then we had 7 out of 50. And again, that one will not simplify. Now, what we can do is you can spin it. So you can put like a paper clip on your paper, spin it around, and get random numbers each time. And we can do that for 50 more times to get our totals, and then calculate our relative frequencies again. Alright, now what you'll notice is that because the spinner is relatively equally divided, most of our answers are going to actually be pretty close to 1/5. Okay, and they're going to get close to 1/5 of the time. And for 20 for 100 spins, that's going to be about 20 in each. Now, some might be farther away than others, but eventually, and if we did 1,000 spins, they would all be close to 200. Not exactly, but somewhere near. All right. So now let's go ahead and calculate what is the theoretical probability of spinning each number. Well, remember, each one shows up 1/5 of the time. So each one of these is going to be 1/5, which, by the way, is 20%. Okay? Now we're going to get that same answer for every single one, because each one is equally likely. Go ahead and get that percent symbol in there. Now, how does the relative frequency change when the spinner is spun 50 times versus 100 times? Alright. Well, we know that the experimental probabilities will approach the theoretical probabilities. Or we can call those experimental probabilities the relative frequency. Okay? Suppose the spinner is spun 1,000 times, predict the relative frequency. Well, the answers are going to be exactly the same. The relative frequency is going to get close to the theoretical probability. Okay, now it's never going to be perfect, but it's going to be close every single time. So go ahead and summarize the lesson, talk about what we've learned today, and what is the difference between theoretical probability and experimental probability. Then go ahead and work on our assignment in ALEX.